My name is Keshwani. That's Keshwani. Keshwani. We are here because we want to prepare for the GRE. We have been solving math problems for GRE out of this book here, the official guide to the GRE, the revised journal test. If you do not own this book already, purchase one immediately. You're going to need it in order for you to be able to follow my work. The problem that we are about to solve is the one that you will find on page number 159, and today is our lesson number 66, day 66. Feel better now. Let's take a look at it. It's not the problem that we are about to do, the bottom problem. It's not a simple problem. Let's read it first together. Make sure that you have the book in front of you. It says, let S be the set of all positive integer n such that n squared is a multiple of both 24 and 108. What the hell does it mean? Let S be a set of all positive integers n such that n squared is a multiple of both 24 and 108. And then it goes on to say, which of the following are divisor of every integer in the set S? Which of the following are divisor? What are divisors? Divisors is just a very fancy, very annoying way of saying factors of every integer in set S. That is the question. I had to read it more than twice before I could sit down and actually start solving it. As I told you, it's not a straightforward question. Let's take a look at it, shall we? It says that n squared is a multiple of both 24 and 108. If that is true, if n squared is a multiple of both 24 and 108, then that implies this statement here. Let me put it in a different color so we can actually emphasize it. This statement that we are told, n squared is a multiple of both 24 and 108, that in turn implies that n squared must also be a multiple of the LCD of 24 and 108. That is the very first step in understanding this question. And if you have trouble understanding this first part, then that's not a good sign. If n squared is a multiple of both 24 and 108, then that implies that this quantity n squared, whatever that quantity is, n squared, the fact that it's squared doesn't matter, it's some number. This number here, we are told, is a multiple of both 24 and 108. Therefore, that number must also be a multiple of both. That number must also be a multiple of the least common denominator. That's what LCD stands for. Least common denominator of 24 and 108. Let me give you an example to make you understand. We're going to do the example on the side so that you understand this thing. These are just vocabulary words that I put together when I was taping the last video for the SAT. Verbatim, succinct, day number 16 when we covered it. Verbose, if you want to learn these words, watch the vocabulary videos of mine. Just type in vocabulary, day 16, and you will learn the word verbose, succinct, superfluous on day 47, and gratuitous. Let's take a look at this example here. I'm not in a hurry, as you can see. I'll go at a very leisurely pace because we are doing it for learning purposes. You understand? Okay. For example, in order to understand this statement that we just made here, in order to understand this statement, I'm going to give you a simpler example. If we are told that 100 is a multiple of both 25 and 10, would you agree to that? That 100 is a multiple of both 25 and 10? Of course it is. 100 is a multiple of 25 because 25 times 4 is 100. 100 is also a multiple of 10 because 10 tens will make 100. So that statement is true. But what this implies is that 100 must also be a multiple of the least common denominator of 25 and 10. 25 and 10 has to be least common denominator. We cannot say, listen carefully, we cannot say that because 100 is a multiple of 25 and 10, therefore 100 must be a multiple of 25 times 10. 100 is not a multiple of 250, but 100 is going to be a multiple of the least common denominator of these two numbers. How do you find the least common denominators of 25 and 10? There are two ways you can do that. One is to break this up into its prime factors, which is 5 times 5, and break this up into its prime factor, which is 5 times 2. This 5 appears here and this 5 appears here. We do not count them twice, we count them once. Whenever two things appear here, we count them once. So here we have 5, and then these two 5 count as 1 5, and then these two right here. So 5 times 5 is 25, times 2 is 50, and therefore the least common denominator of 25 and 10 is 50. And therefore, if 100 is a multiple of 25 and 10, it better be a multiple of 50, which of course it is 2 times 50. Another way we can find out the least common denominator of 25 and 10, a quicker way, this is a bit of a childish way, a quicker way would be something like this. Put down 25 here, put down 10 here, and you start dividing by the least prime factors that we can find. We cannot divide by 2 because 2 does not go into 25. It does go into 10 but doesn't go into 25. 3 won't work, let's try 5. 5 and 2, there you go, we're done, that's it. And as soon as you get the prime factors everywhere, you're done. This is the prime, 5 is a prime number, this is a prime number, this is a prime number, you're done. So the least common denominator of 25 and 10 is 5 times 5 times 2. Voila, 50 is the least common denominator. That is exactly what we have to do here. We have to find the least common denominator of 24 and 100, or 108. Let's do that, okay? Let's do that. We need to find the least common denominator of 24 and 108, and we're going to do it exact same way as this one. So 24 and 108, let's divide by 2 because 2 is the smallest prime number that will go into both of them. Has to go into both, obviously. So this becomes 12 and this becomes, how many 2's in 1? There is 0, 2, so you could take 10. How many 2's in a 10? There are 5. And then how many 2's in an 8? There are 4. This is an even number, that's an even number. Let's go one more round. So this becomes 6. How many 2's in a 5? How many 2's in a 5? There are 2 2's in a 5. The remaining one goes and joins this guy, becomes 14. How many 2's in a 14? There are 7 of them. In other words, 27 times 2 is going to give us 54. We can no longer divide by 2. This is an even number, it will go into 2, but this won't. So let's try 3. So 6 divided by 3 is 2, and 27 divided by 3 is 9. That's it. That's about it. Even though this is not a prime number, we could do one more thing, but it's not going to do anything here because nothing will. As long as you stop the process, when you're no longer able to divide both of these numbers. This is it. This is even though this is not a prime number, but this is going to give us the least common factor, least common denominator rather. 9 times 2 times 3 times 2 times 2. I'm running out of room, so I need to erase the top part and continue from top, okay? Just keep listening. We will get there eventually. So what this implies is that, I need the room as I said, so I'm going to erase everything from the top, everything. So what we have found is that n squared must also be a multiple of, so this tells us, this part that we just did here, tells us that n squared must also be a multiple of 2, right here, I'm going to point as I write here, 2 times 2 times 3 times 2 times 9. So far so good? Are you with me in this story so far? Okay. As I said, we're going to take our time. We're not going to rush here. And this quantity is some, n squared is some multiple of this quantity. One more time, n squared is some multiple of this quantity. Therefore, we can write this as n squared equals some multiple. Let's call that multiple k. K is some multiple, or if you don't like k, put down m for multiple if you like. It doesn't really matter. But m is going to confuse you with n here. K is some multiple. This quantity is some multiple of this quantity here. 2 times 2 times 9 times 3 times 2. Now if you're wondering why I put a 9 here and then 3 and 2 here, there is a reason for it. Now keep listening, because this is an n squared, a quantity that is a number, for example, 5 squared, a quantity such as this one is called a perfect square. It's a perfect square because 5 squared is 25 and square root of 25 is 5 obviously. So n squared, if it's a 5 squared, means whatever follows here has to be a perfect square. If I tell you that if I put down 7 squared, then whatever follows here must be a perfect square. So if I write here 40 times 9, this quantity 40 plus 9, whatever that happens to be, is going to be a perfect square because I just told you that that equals 7 squared. So this has to be a perfect square. Okay, this has to be, the right hand side has to be a perfect square. See what happens? Watch what happens. This we know is a perfect square. 2 times 2 is a perfect square. 9 we know is a perfect square. 6 is not. So how k times this quantity has to be a perfect square. That tells us that this implies that k must be 6. This statement implies that k must be either 6 or 4 times 6, because 4 is a perfect square. I'm going to erase this part, we are done with it. K must be either 6, because if you replace k with 6 here, then this 6 times 6 becomes 36, which is the n squared. So k must be either 6 or 6 times 4, because 4 is a perfect square, or 6 times 9, or 6 times 16, or 6 times 25. You get the idea, so on and so forth. But we only need to worry about the least one. But we need to worry only about the least one. Why the least one? Because if anything, the question was which of the following numbers are the factors of the numbers in the set there. Listen carefully. The question was which of the following numbers, the numbers that they give us here, 12, 24, 36 and 72, which of them are factors of the numbers in the set that we're going to find? Well, in order for these numbers to be factors of every number in the set, as long as they are factors of the smallest number in the set, they're also going to be the factors of anything that is a multiple of that number. So if a number happens to be, say for example here, k, if number happens to be some multiple of this quantity, and if k happens to be 6 here, then that number must also be a multiple of 6 times 4. or 6 times 9 or 6 times 25. So we only have to worry about the smallest one. We're not going to worry about all of them because it doesn't matter. When we get to it, I'll show you one more time. So we only have to worry about the least one. Hence n squared, again I need the room, I'm going to continue here. Hence n squared must equal 2 times 2, which is 4, times 9, times 3 times 2, and k we just said the smallest one we're going to worry about is 6. So if you replace k with 6 here, 6 times 6 is 36. We're almost there. And that implies, finally, that n must be 2 times 3 times 6, or 36. Voila. Of course, in reality, we know that n can be 36 or 36 times 2 or 36 times 3, because we have, I erased it here. It could be 6 or 6 times 4. If it's 6 times 4, the square root of that is going to be 2. It could be 6 times 9, and the square root of 9 is going to be 3. So in reality, the n that we just found could be 36 or 36 times 2 or 36 times 3 or 36 times 4 and so on and so forth. And that's going to be our set. Okay? And therefore, the set S consists of 36 or 2 times 36 or 3 times 36 or 4 times 36 and so on and so forth. That's your set. We are almost there. Almost there. Again, I need a lot of room, so I'm going to erase everything. You have everything here, and of course the beauty of this technology, you can always go back and watch it again. I don't know why I need to repeat that thing. Must be a geyser effect. Okay, let's erase this thing, shall we? We are almost there. So that's our set. We found the set. Now the question is, I'm going to actually write down the question. It says, which of the following integers are divisors factors are divisors, which we know simply means factors. Which of the following integers are divisors of every integer n in S, of every integer n in set S. And the very first one that they give us is 36. Well, let's ask ourselves. Let's stop. Oh no, sorry. Very first one they give us is not 36. I don't know why I have, what the hell? Very first one they give us is 12. Well, we are almost there. Is 12 a factor of 36? Is 12 a factor of 36? That's the first number in the set. The answer, of course, is yes. 12 is a factor of 36. To be a factor of 36 simply means that 36 can be divided evenly by 12. 36 divided by 12 is going to give you an even round number of 3. It's not going to be 3.27. It can be divided evenly. So 12 is a factor of 36. Now you know why we don't have to worry about any of these, because any number that is a factor of 36 must also be a factor of this guy and that guy and that guy. We only have to worry about the smallest one. So 12, one more time, is a factor of 36. A works. A works. Let's look at B. What they give you in B? 24. Is 24 a factor of 36? In other words, In other words, can 36 be evenly divided by 24? Well, let's find out, shall we? 36 divided by 24. If you divide top and bottom by 12, it's going to be 3 halves. Of course you knew that it does not go evenly into it. 24 is not a factor of 36. In other words, there exists no integer where you can just do 24 times some number and which is going to give you 36. Like here, for example, there does exist a number where you can do 12 times some number and gives you 36, and that number of course is 3. 12 times 3 gives you 36, so 12 is a factor of 36. You cannot multiply 24 by any integer. You cannot multiply 24 by any integers to get 36. It's not possible. It doesn't go evenly. So B is not the right answer. What did they give you in C? Oh, C is very complicated, isn't it? C is very complicated. Oh, we're done with B, that's it. We're done with B. Let's look at C. Oh, here's a tough one for us. Is 36 a factor of 36? Bloody hell, of course it is. 36 divided by 36 is 1. So that works. What's the last one? 72. Now this is a tough, this is not, I was about to say this is a tough one. It's not a tough one, it's a tricky one. You have to pay attention. Listen carefully, okay? Is 72 a factor of 36? The answer is no. 72 is not a factor of 36, but 36 is a factor of 72. You can divide 72 by 36 and get a 2, but if you try to divide 36 by 72, 36 does not go evenly into 72. In other words, this top number is not a multiple of this bottom number. It does not work. That's it. The answer is A and C. Answer is A and C. I said it twice. What I should have said is that answers are A and C. The statement that I made, and I made it two statements in a row, exact same statement in a row, which was a silly sentence. I said, so the answer is, and then I went on to say A and C. The answers are, plural. That's it, we are done. The answer is A. There we go again. The answers are A and C. Now what I'm going to do here, quickly, is to show you all the factors of 36. We are done. That's it, we are done. This is it. Where can we show the factors of 36? Let's do it here. Factors of 36. You start with 1. 36 can be divided by 2. 36 can be divided by 3. Evenly, that is. 36 can be divided by 4. 36 cannot be divided by 5. It does go into 6. It doesn't go into 7 or 8. 8 fours are 32, not 36, so that's not going to go evenly. 9, 10, 11, 12. 13, 14, 15, 16, no. 13, 14, 16 cannot be divided. 18 would work, because 18 times 2 is 36, and finally 36. Out of all of these factors that are given to us, out of all of these factors that you see here, the only two factors that are given in the list here, the list was 12. I'm going to actually put them in the, because by now you know that we do have flair for the dramatic. So what I'm going to do now is finally, what was the B? The B was, what was the answer in B? B was 24. And that doesn't work. And as you can see there, these are the four answer choices we have here. These are the four answer choices we have here. Out of all of these numbers that you see here, and these are the factors of 36, which one do you see out of these four? I see a 12. I see a 12. I don't see any 18. Had there been 18 here, that would have been a right answer. I see 36, which is the very last one. And that's it. Once you reach the very last one, that's it. This doesn't work. That 24 doesn't work. 24 doesn't appear there. 12 appears there, but not 24. That's all. The answer is A and C. Now when I go back to the camera, I will actually find out how long I took, and hopefully the mere fact that you're still watching, that means you're still with me, and That's a lot of patience. When I come across a tough problem, we're not here to simply solve the problem for the sake of solving the problem. If I just wanted to solve the problem, we would have been done with it in 2 minutes. We are here for learning purposes, for those of you who actually had trouble with it. And that requires time, and that requires patience. Once you understand the concept, if you happen to come across something like this in the real exam, hopefully you will be able to tackle it. You will not be intimidated. It is not a difficult question, but it does require thinking and it does require patience. But math itself that is involved in it, there is no complicated math in here. It's a simple math of finding factors and multiples and so forth. Very straightforward. And understanding the language that they use, that's what it is. I'm done with my sermon. I will see you tomorrow on day number 67, where we'll do the next problem. Okay? Hopefully the next problem will go a little bit faster. Bye now.